Hey everyone, Dan here, just to sort of show you and go over how to make a calculation tool for sort of solving the Newton's law of universal gravitation, which is this equation right here, F equals negative G m1 m2 over r squared. And so today what we're going to be doing is in Desmos sort of creating our own tool to go over and sort of be able to solve for the various components of this equation, as long as you understand what your givens are and be able to just sort of plug them in and calculate it without having to worry too much about whether or not you made any sort of calculation error. So it's mostly for us to be able to know and recognize when we're using the correct equation. So to get us started, what we'll need to do is go to Desmos. And so on Desmos, you'll need to create a graph. I would suggest after logging in, give the graph a name. So we could call it something like Newton's law of universal gravitation. And so we can save that, and so make sure you're logged in. If you're not logged in, click up here, it should say sign in, and then you can just sort of click sign in, and that'll allow you to be able to save your graph, because this will be a useful tool for you in the future and on quizzes. So first things first, we want to make it about the Newton's law of universal gravitation. So we'll just sort of here add an expression, and we'll just call it base equation. And so we'll type in the equation. We'll say F equals G times, and then we'll do M and then underscore 1, and then M, shift M, and then underscore again, 2, and we'll highlight all of this, and we'll hit division, and now we'll do R, and then caret, which is shift 6, squared, and we'll sort of add sliders for all of these, so we can sort of do all that and get that all in here. And so what we'll do now is also go back to our original thing, because G is a constant, so we actually have a value for that. So for G, we have 6.67 times 6.673 times 10 to the negative 11. So we'll type that in here, 6.673 times 10 to the negative 11. And so that's what we'll have for there. So we have our base equation, and we're also going to add a slider for F. F equals, and we'll just sort of keep it blank. We'll make it a slider as well. And so what we'll do is, so this is our base equation. And now what we're going to do is, like we did with the Kepler's third law, we're going to sort of add a folder and label this folder for what we want to solve for first. So we'll say solve for F. And so we'll do that, and then we'll basically just sort of copy and paste this here. And so we'll do that. And so that'll give you, if we plug in our M1, our M2, and our R, that'll give us our force. So what we want to do now is solve for one of the other things. And so if we do that, so now let's say we want to solve for another thing. So what we'll do is we'll make a folder, and we'll say solve for M1, which actually maybe, nope, I cannot quite do that there. So we'll solve for M1. Now, to do this, we'll need a little bit of math. So let me switch over to my magic thing. Oh, slightly wrong. Okay, so we have our whiteboard, my magic whiteboard, and so we'll solve for M1. So to start us off, we can treat this kind of like some algebra problems. So we can sort of go through, and we're going to just sort of isolate our M1. on this side, and we'll try and get everything else on the other side. So what I think I'll do first is I'll divide both sides by g divided by g. And so when we do that, we get f over g equals m1 m2 over r squared. And next, I think what I'll do is multiply by r squared. Sort of help solve that out. So when we do that, we get f r squared. And so we can put the r squared on the top because we're doing multiplication, and then all divided by g equals m1 m2. And so what I'll do from here is we're going to divide by m2. Now, one of the key things here is that since we're dividing by m2, we can actually use pretty much the same equation to solve for m1 as we do for m2. And let me make this a little bit smaller. So we can, like, if we divide by m2, it's the same as if we were to divide by m1. And so when we get this, we can just basically interchange m1 and m2. So we have m2g equals m1. And so this would be a possible solution for us to solve for m1. And we can just swap 1 and 2 if we wanted to, say, solve for m2 instead of m1, because overall, like in the grand scheme of things, it doesn't make a lot of difference which mass you label as mass 1 and mass 2. It's pretty much the same equation to calculate for both of them. So let's go back to our Desmos and let's put in that equation. So with it, we have f times r squared. So that's the shift r, and then I'll highlight all of this, do the division, and say g m, and then underscore 2. And so I'll copy that. And why isn't it? Let me see, let me pause. All right, so I think I'm gonna sort of rename this to F1. And we'll sort of say F1 here, because apparently I need to fix that, otherwise it is unhappy. So we'll sort of label all those as F1, so force versus base equation, just because otherwise it gets a little confused. So if you have your force, you'd want to plug it in here to sort of play around with it. All right, so we solve for M1, and then we can basically make a folder similar to this to solve for M2. Which, as you probably know, is the same as this. So we can just copy and paste this, and we can just swap out the 2 for a 1, and we're golden. All right, so now that we've solved for M2, we need to now solve for our last thing, which would be R. So I'm going to make a folder that says solve for R. I'll do R in lowercase, and so we'll hit enter here, and now we'll swap back to the whiteboard. And so we'll start back up at the beginning. I'm going to rewrite the equation so then I can start solving for R. So I have F equals G M1 M2 over R squared. And so what I'm going to do is I'm going to multiply both sides by R squared again. And so that cancels it out on the right side, and so we're left with F R squared equals G M1 M2. And so those are all being multiplied. And now what I'm going to do is just do a quick division, divide both sides by F. And so then now what we're left with is R squared equals G M1 M2 over F. And now I'm going to do the coup d'etat and just take the square root of both sides. So when we take the square root of R squared, we're left with R. And so we get R equals the square root of G M1 M2 over F. And so this will be our final equation we'll be using. So when we swap back to Desmos, we can go ahead and start typing that in. So we have the square root, so we type SQRT, and then we'll do G, and then we'll do M1, shift underscore 1, shift M underscore 2, and then division F. And so when we do all that, we get some, F and then underscore 1. So then we can sort of solve all of these pretty quickly. So now what we can do is we can hide all of these, and we can click save, and now we can sort of utilize this as sort of a quick way to solve some of our problems. So let's put it to the test by utilizing it for our calculating the weight of an object on Earth's surface. So what we'll do is we'll plug in Earth's mass as M1. So M1 was 5.97. 97 times, not plus, times, so that would be the asterisk 10, and then shift caret to the 24th. And then M2, when we looked at it, was 2 kilograms. And then R, when we hop back, is going to be the radius of the Earth, which is 6.378 times, so shift 8 again, 10, and then shift caret to the 6. And so when we calculate that out, we end up with, to solve for F1, we end up with 19.58648, which it also appears up here if you're just trying to solve for force, but it's just good to remind ourselves of the base equation up here and sort of separate it out so we can solve for those. So you should be able to use this to solve the equations, these problems, which will actually be in a separate worksheet for you to turn in during our asynchronous days. So I hope this helped you. Feel free to reach out if you have any trouble, but make sure after you've updated it, you have click save up here. And so make sure it says like no unsaved changes, so that way you can keep reusing this particular tool. So that is all, and have a nice day.